You open a few tabs, then a few more, then 20. Your laptop fans spin up. Everything starts to lag, so you open the task manager. And there it is, your browser, eating gigabytes of RAM, so you blame the browser. It's bloated. It's badly made. It's a memory hog. But that's not the real story. Your browser is using that memory on purpose. Today we take it apart. Here's the first thing to unlearn. A tab is not a document, it's a running program. Open a tab, and your browser launches a whole separate process for it. Its own little sealed box. Why go to all that trouble? 2 reasons. Security and stability. If one tab crashes, it dies alone. The rest of your tabs keep running, and a shady site in one tab can't reach into another to read your bank login. Each tab is walled off from the rest, but walls cost memory. Every one of those processes carries its own baseline, its own private copy of the engine that runs the page. So 20 tabs isn't one program using a lot, it's 20 programs, each using a little, and that adds up fast. Now open your browser's own task manager. Count the entries. There are more of them than you have tabs, because the browser itself is split into pieces. One process draws the interface you click on, another handles the network. Another one, the GPU process, paints everything onto your screen. And then there are your extensions. Every extension you install runs in its own process too. An ad blocker, a password manager, a grammar checker. Each one quietly holds its own slice of memory. So before you open a single tab, the browser's already a small crowd of programs. Add tabs on top, and the crowd grows. Now open just one tab and look inside it. It is not just text. The page loads as a tree of objects in memory. Every button, every image, every box is a live object. Then come the images. On disk, a photo is compressed and small. To show it, the browser has to unpack it. A tiny 200 kilobyte image can balloon to several megabytes once it's decoded, and a page can hold dozens of them. Then custom fonts download and load in. Any video keeps frames buffered in memory, ready to play. Then there's the JavaScript. Modern sites ship enormous amounts of code, entire app frameworks running inside the page, and that code claims memory for everything it does. A single tab can be a full application, not a sheet of paper. A running program, with a running program inside it. Here's where the memory really climbs. Your browser is obsessed with speed, so it holds on to things instead of throwing them away. Decoded images stay in memory, ready to redraw instantly. Compiled code stays cached, ready to run again. Graphics get uploaded to your GPU and held there as textures, and when you switch away from a tab, it doesn't shut down. It stays fully loaded in the background, its entire state just sitting in RAM. So the second you click back, it's there. No reload, no wait. That speed has a price, and the price is memory. The browser is trading RAM for a faster experience, on purpose. Now think about the tab you opened 3 days ago. The email tab, the chat tab, the dock you never closed. Those are the quiet monsters. A web app that stays open keeps building up state. More messages loaded, more data cached, more objects created. And some of that memory never gets released. It's called a memory leak. The app claims memory and then simply forgets to give it back. A fresh tab is light. A tab that's been open for days has been growing the entire time. The longer it lives, the more it eats. Now here's the part that flips everything. You see your browser using 10 gigabytes and you panic. Don't. Here's the rule almost nobody knows. Unused RAM is wasted. RAM. Empty memory isn't doing anything for you. It just sits there, idle. RAM exists to be filled, so your operating system and your browser fill it on purpose. Using 10 gigabytes out of 16 is not a problem. It's the system doing its job. The real trouble starts at one specific moment, when something demands more memory than you physically have. Because now the computer has nowhere to put it, so it takes the overflow and dumps it onto your disk. That move is called swapping, and your disk is thousands of times slower than RAM. Now every time the system needs that data, it crawls to the disk to fetch it, back and forth, over and over. The system starts spending more time moving memory than using it. Engineers call it thrashing. The machine is working harder than ever and getting less done. That is the lag you actually feel, not the big number, the moment you ran out. So what do you actually do? First, stop panicking about the number. High memory use is normal and usually fine. The goal is simple. Don't run out. Modern browsers have a setting built for exactly this. It puts idle tabs to sleep and frees their memory. When you click back, the tab quietly reloads itself. Turn it on. Then close the tabs you are truly done with, especially the old leaky ones you forgot. And if you constantly max out your memory, more RAM genuinely helps. It simply raises the ceiling before swapping kicks in. A faster disk softens the fall when you do swap, but it never matches RAM. But for most people, the fix isn't fewer tabs. It's letting the browser sleep the ones you forgot about. So put it all together. Every tab is its own walled-off program. Every page is a full app holding a tree of objects, decoded images, and running code. The browser keeps it all warm in memory to stay fast. And the tabs you leave open for days quietly grow and leak. That's why the number gets big. But the big number was never the enemy. The enemy is running out and spilling over onto the disk. Your browser isn't broken. It's using your memory exactly the way memory is meant to be used. That's why your tabs eat all your RAM. If this changed how you see that task manager, drop a like. Subscribe if you want more of how your tech actually works. And tell me in the comments what I should take apart next. Thanks for watching. See you in the next one.